Hello friends, in this video we are going to discuss resistance temperature detector or RTD or resistance thermometer. Resistance thermometers are also known as resistance temperature detector. It is basically used for measurement of temperature. If we want to measure the body of temperature, we are used the thermometers, or for room temperature also used thermometer. So just like that, if we want to measure temperature changes in metal, what we do? It is very difficult to measure it indirectly, the measure of temperature in metal. Then we follow indirect process. We measure the temperature changes by measuring the change in resistance, because as the temperature changes, the resistance already changes. Working principle. It is known that the resistance of a conducting material changes with temperature. This property can be utilized to measure temperature by finding the amount of change in resistance due to change in temperature. Now, how the resistance changes with respect to temperature? We know that resistance is defined as the property of material to oppose how flow of current through it. In a conductor, if more amount of current flow through it, that is resistance is very less, and if less amount of current is flow through the conductor, it means it has a high value of resistance. Now this resistance not only depends on current but also depend on temperature. When a conductor is heated up, that means if thermal energy is provided to the conductors, or thermal expansion is given, then due to thermal expansion the electron, because the flow of current is all the flow of electron, the flow of electrons increases due to thermal expansion. As the flow of electron increases, flow of amount of current is also increased and the resistance decreasing. So we can say that there is a relationship between temperature and the resistance also. As we increase the temperature, the resistance decreasing, because when temperature increase, the flow of electron increase and the flow of current increase, and so the resistance is decreased. And when the temperature decreases, resistance decreases. We are going to use here the relation between temperature and resistance to measure the temperature variation. Construction of RTD. The requirement of material used for making RTD are change in resistance with change in temperature should be high. That is, the material should be high value of temperature. The resistive element used should not undergo any permanent change with temperature and it over a period of time. The change in resistance with change in temperature should be linear over a wide range of temperature. The volume of material required to make an RTD should be small. This will make the sensing element of same size. Consequently, less heat will be required to raise the temperature. This will make the RTD suitable for measurement of repeatedly changing temperature. Metals commonly used for making RTD is platinum, nickel, copper and nickel alloys are suitable for making RTDs. Relation between temperature and resistance of RTD is given as RT is equal to 1 plus alpha T into R0, where RT is the resistance of RTD at T degree. R0 is the resistance of RTD at 0 degree. Alpha is the temperature coefficient of resistance. T is the resin temperature. A high value of alpha is desirable so that there is a suitable substational change in resistance per unit change in temperature. Figure shown an industrial platinum resistance thermometer. The platinum sensing element has a resistance of Rs. This is the platinum sensing element, whose resistance is Ra, and the diameter of the element is 6 to 12 mm. This is the sheath or cover of the sensing element. The both are the connecting leads. And this is the threading for mounting. And this is a Western bridge. This is a RTD. Resistance R1, R2 and R4 are constant value resistance. By properly selecting the values of R1, R2 and R4, the bridge can be balanced such that the following relationship holds good. That's R1 by R2 is equal to Rs by R4, or Rs is equal to, from here, R1 by R2 into R4. Rs is the resistance of the platinum sensing element in normal temperature. The value of resistance Rs will be increased because of small value of resistance of the lead wires. Once the bridge is balanced under normal condition, the galvanometer will give zero deflection when the bridge is under a balanced condition. That means when R1 by R2 is equal to Rs by R4. When temperature increased here, the value of Rs will be increased, and hence the galvanometer will show some deflection due to voltage appearing across the bridge terminals B and T, a voltage VDC. The more will be the temperature rise, the more will be the unbalanced condition, and the more will be the deflection of the galvanometer pointers. The galvanometer's deflection can be calibrated in terms of temperature rise of the substance on which the RTD has been fixed. Thus, the RTD can be used to measure temperature from a distance.